Talk about condensation reactions. And this is a reaction where two molecules come together to form a larger molecule, and it eliminates a smaller molecule, okay, such as water or HCl. So for example, we can have an alcohol with a carboxylic acid reacting to form an ester and a water. And if we actually look at it written out, here is a carboxylic acid, carboxyl group, with the ethanol, with the hydroxyl group. Okay, the OH with the H, okay, the OH of the ethanoic acid and the H of the alcohol bonding together to form the water. And then you form the ester because I've got this oxygen here. Okay, so these come together forming the ester. Thing to remember about esters, they have a distinctive fruity smell. If you look at the structure, remember, because I have this OH bond in both the ethanoic acid and in the alcohol, I have the possibility for hydrogen bonding between this molecule and a neighboring molecule because of the electronegativity of this oxygen pulling that electron cloud, leaving this hydrogen very, very positive, okay, very attractive to the negative oxygen in a neighboring molecule. Remember, IMF is between molecules, and the IMFs are what are broken to turn things from a liquid to a vapor. Okay. Oh, so esters, because it's missing any ability to hydrogen bond, because I don't have any hydrogens bonded to an oxygen, nitrogen, or fluorine, is now just a dipole-dipole intermolecular force. A little weaker, so they're more volatile. You get that fruity smell. Right? They're used as natural and artificial flavorings in foods. We'll find later when we do the special topics that esters are also used as plasticizers, and these are substances that are added to polymers, plastics, like PVC, polyvinyl chlorine, to make them more flexible. The phthalate esters, esters of phthalic acid, there's a lot of health concerns with those now, and those are, if you paid attention to the news a little while ago, those are the things that leach out of those plastic water bottles. All right, so general reaction, and here's another example of specific condensation reaction for the carboxylic acid with an amine. Again, I've got the carboxylic acid with this OH group, the amine with the hydrogen on the nitrogen. They will come together to form water, and then the two organic compounds join to form an amide with the grouping right there. Okay. Hopefully this makes sense, seeing it worked out. This particular example is pretty important because of biological reactions. The amino acids contain an amine group and a carboxylic group. They can condense in the presence of enzymes to form polyamides, right? So more than one of that. And this peptide link right here is called a peptide bond, and they are obviously in peptides. That's biological stuff. Yeah. Okay, condensation, polymerization. Okay, if you have two reactants in a condensation reaction that have two functional groups that can undergo condensation, you can form a long chain because they can form or attach to another organic on either side. So you can get these long chains of polymers. And that's where you get things like proteins from the polypeptides. Okay. So for example, see how in this benzene 1,4-dicarboxylic acid, I have a carboxylic acid on either side of the benzene. So, and if I have this dicarboxylic acid with a diol, I've got two opportunities for this to condense into a polymer. Here, forming a water, and then on this side it can also do the same thing. So you'll see this repeating unit. This particular unit is at dacron, which is a type of polyester, right? And then condensation, because I still get the water molecule. You are expected to be able to draw these. Another example is with hexane 1,6-dioic acid. Structure looks like that. And 1,6-diaminohexane. Structure looking like that. Okay, coming together, we have that peptide bond, that amide link. Okay, and these two together, because I've got more opportunities to bond on either side, being a repeating unit with a large polymer. Okay, this repeating unit is called nylon 6,6, and it's because each monomer here contains those 6 carbon atoms. Okay. And then we would go on to the pathways.